All right, so you're ready to take on ClickHouse's MergeTree engine.
We're going to jump right into it.
We're going deep today.
That's right, a deep dive into MergeTree.
Think of it this way. ClickHouse is this crazy fast database.
Built for analyzing huge amounts of data.
And MergeTree
That's the engine that makes it all possible.
makes all that speed possible.
Exactly.
And we've got a fantastic article to guide us.
From productindata.com.
By the end, you'll understand how MergeTree structures all that data.
How it balances writing and reading data efficiently.
Even some of the more complex stuff.
Like how it handles deleting data.
And replicating it across multiple servers.
It's a pretty incredible system when you get down to it.
Okay, let's start with the basics. MergeTree overview. What's the core idea?
Well, MergeTree breaks your data down into, think of them like containers.
Containers?
Yeah, we call them parts.
Parts, okay.
And it's constantly merging these smaller parts into larger ones.
In the back.
Yeah, all behind the scenes. This whole
Yeah.
approach is based on something called an LSM tree,
LSM tree, okay.
which is all about making those writes as fast as possible.
So it's optimized for getting that data in quickly.
Exactly.
But why is that so important for data analysis?
Well, think about it. If you're analyzing real-time data,
Yeah.
like, website traffic
Oh, yeah, good point.
or stock prices.
Yeah, things that are constantly changing.
Right, you need to be able to ingest a huge amount of data super fast.
Makes sense.
And that's where this LSM tree structure really shines.
Gotcha.
It lets ClickHouse handle that constant flow of information without slowing down.
So it can keep up.
Yeah, exactly. Of course, there are some trade-offs.
Like what?
Well, you need to do some extra work later to sort and organize everything.
That makes sense of it all.
Right. But for analytics, that initial speed is crucial.
I can see that.
You need that data as fast as possible.
Okay, and the data itself, it's all stored in columns, right?
Yes, but ClickHouse has a bit of a unique approach.
Oh. How so?
Well, unlike some other columnar databases like Parquet or BigQuery,
Okay.
ClickHouse stores each column completely separately.
Really? Completely separate.
Yep. It actually offers two formats. Wide,
Why?
with separate files for each column.
Okay.
That works great for larger data sets.
All right.
And then there's compact,
Compact.
where all the columns are in a single file.
In one file.
Yeah, but that's usually for smaller parts.
So it's almost like having different filing systems.
Kinda.
Depending on how much data you have.
Exactly.
Why the two options?
It all comes down to performance.
Okay, performance.
For those big data sets,
Yeah.
separating the columns lets ClickHouse read only the data it needs.
For a specific query.
Right. But for smaller parts, keeping everything together in one file actually reduces overhead.
And that makes things faster.
Exactly. Less to manage.
Interesting. So we've got our data organized into these parts,
Right.
stored in columns,
Yep.
sometimes together, sometimes separate, all for efficiency. What about finding the data quickly?
Ah, that's where indexing comes in.
Okay, indexing.
MergeTree uses something called a sparse index based on the primary key.
Sparse index based on the primary key.
Yeah. Think of it kind of like a building directory.
A building directory.
Yeah, it lists the floors, but not every single apartment.
Okay, I see.
It gives you a general idea of where to find things, but it doesn't list every single entry.
Gotcha. So instead of indexing every single row, which I imagine would be incredibly resource intensive,
Oh, yeah.
it points to ranges of data.
Right.
That makes a lot of sense for handling these massive data sets.
Exactly. You don't want to be indexing everything.
Now, I'm curious, how does all of this actually look under the hood?
Well, imagine your data is organized like a really well-structured filing system.
Okay, like files and folders.
Yeah, perfect. Each part is like a folder,
A folder,
and it contains files for each column.
and some extra files with metadata.
Exactly. You got it.
And those folders, they have some interesting names.
They do, yeah.
I've seen some crazy combinations of numbers and letters.
You have.
What's that all about?
Well, those names aren't random at all.
I figured.
They actually tell you a ton about the part,
Like what?
when it was created,
Right.
what data it contains,
Yeah, okay.
and even how many times it's been merged with other parts.
How many times it's been merged?
Yeah. That's indicated by the level in the name. The more merges, the higher the level.
So it's like those parts are leveling up as they get merged.
Exactly. I like that.
What else is going on within these folders?
Well, you've got granules. Think of them like groups of 892 records.
Okay, 8192, got it.
And then you've got blocks,
Blocks.
which are groups of granules compressed together.
Compressed together. Why is that?
Well, it's for efficient storage and retrieval.
So it's like when you're packing boxes for a move,
That's a great analogy.
you group similar items together to save space.
Right. And it makes unpacking so much easier later.
So these granules, they help ClickHouse compress data.
And find it quickly.
Exactly. It's all about speed and efficiency.
And there are also these things called MARC files, right?
Oh, yeah, the MARC files.
What are those for?
Okay, imagine you're looking for a specific quote in a really big book.
Okay.
MARC files are like bookmarks.
Bookmarks. Okay.
They tell ClickHouse exactly where to find the data it needs within those compressed blocks.
I see. So they're like maps to specific pieces of data.
Exactly. And that makes queries really fast.
Okay, so let me see if I've got all this straight.
Okay.
We've got parts acting like folders,
Right.
data stored in columns,
Mm-hmm.
sometimes in separate files, sometimes bundled together.
You got it.
Then there's that sparse index acting like a building directory,
Right.
and MARC files, which are like bookmarks pointing to specific information.
Exactly.
This is pretty complex.
Yeah, it can be a little mind-bending at first.
But it's fascinating to see how it's all designed for speed and efficiency.
It's a really well-designed system.
Yep.
But we haven't even talked about how data gets written to disk yet.
That's true. We haven't.
There are two main ways to get data into a merge tree table, right?
You got it.
And they involve some interesting trade-offs.
They do. Some interesting trade-offs.
Okay, let's get into that. Tell me about these two ways to insert data.
All right. So you've got synchronous and asynchronous modes.
Synchronous and asynchronous.
Think of it like choosing between making a bunch of small trips to the bank
The hottest little trip.
versus saving up and making one big deposit.
Okay, I like that analogy. So synchronous is like you get a few dollars and you run right to the bank.
Exactly. Each insert statement triggers the creation of a new part immediately.
Wow, right away.
Yeah, it's really good for real-time update.
Where you need the data right away.
Immediately. But, it can create a lot of small parts,
Okay, so lots of little parts.
which can lead to more merging later on.
Makes sense.
It's a trade-off.
And I'm guessing asynchronous mode is like that big deposit at the end of the month.
Precisely. ClickHouse buffers the rows
It holds on to them.
from multiple insert statements and only creates a new part when that buffer is full
Okay, so it waits.
or after a certain amount of time has passed.
So it's more efficient for batch inserts.
Absolutely, you're grouping those writes together.
But maybe a tiny bit of a delay.
Yeah, there might be a small delay before you see the data.
That makes sense.
Mm.
So we choose our insertion mode. We send our data to ClickHouse.
Right.
Walk me through what happens next.
All right, let's do it.
How does that data actually get written to disk?
Well, picture a well-organized assembly line.
An assembly line, okay.
First, ClickHouse parses your SQL statement.
To understand the data, right.
Exactly.
What happens next?
It creates something called a sink to receive the data.
A sink.
Yeah, think of it like the entry point on that assembly line.
So the sink is like where the raw materials arrive.
Exactly. That's a good way to put it.
Then what?
As the data comes in, ClickHouse forms in-memory blocks.
Blocks, okay.
These are like packages ready to be shipped off to storage.
Ready for storage.
And if you have a partition table,
If my table is partitioned,
ClickHouse figures out which partition each block belongs to.
based on the rules you set up.
Right. Kind of like sorting mail by zip code.
So we've got our packages, they're labeled, they're ready to go. What happens next?
It's time to actually write those blocks to disk.
Write them to disk.
ClickHouse starts gathering information.
About each column.
Exactly.
Name, data type.
Yeah, all that good stuff. And for partition tables, the min and max values for the partition expression.
So it's creating this detailed shipping label for each package.
Exactly. Making sure each one has all the right information before it gets stored away.
Then what?
Well, it creates a unique name for the new part based on that naming convention.
Right, that crazy combination of numbers and letters.
Yep. And it creates a temporary directory to hold everything.
To hold the data while it's being written.
Exactly. Like a staging area where everything is organized and prepped.
Before it goes to its final destination.
Perfect analogy.
Now remember how merge tree tables can be sorted?
Yeah, by the primary key or the order by Y clause.
That's to organize the data within a part, right?
Precisely.
So what happens then?
Well, ClickHouse sorts the data in each block based on those sorts of columns.
So everything's in order before it gets stored.
Exactly. And then it uses a writer.
A writer?
Yeah, to handle the actual writing process.
What kind of?
In this case, we're talking about the wide writer, meaning each column gets its own file.
So it's like a team carefully unpacking each box and placing items in their designated spots.
You're getting it?
So the data for each column gets written to its own file.
Yes.
Compress.
Usually using LZ4
LZ4, okay.
and then save to disk.
And the mark files and primary index files.
Oh yeah, they're written at this stage too.
So all the essential pieces are coming together.
Falling into place.
What happens after all that?
Well, ClickHouse is really big on data integrity.
Okay, so it double checks everything.
Oh, absolutely. It writes a few more metadata files.
What kind of files?
Things like count.txt.
Count.txt.
To store the number of rows in the part.
Okay, so it counts the rows.
Then column.txt.
Column.txt.
To describe the columns.
Right.
Default compression codec.txt. To keep track of what compression algorithm was used.
Wow, it keeps track of everything.
And of course, a checksums.txt file to make sure nothing got corrupted.
It's like taking inventory before closing up shop for the night.
That's a good way to think about it.
Just making sure everything is in order.
Precisely.
What happens next?
Well, as a final step, ClickHouse runs some checks.
Before doing what?
Before renaming that temporary directory to the final part name.
So it double checks everything one last time.
Absolutely.
What kind of checks are we talking about?
It makes sure the part isn't affecting multiple tables.
Okay.
Checks for any overlapping data.
Gotcha.
Make sure it's not empty. And that it's not a duplicate.
It's a very thorough final quality control check.
It is. We want to make sure everything is absolutely perfect.
I can appreciate that. So once those checks pass...
ClickHouse renames the temporary folder.
Okay.
Commits the transaction.
And boom, the data is safely stored on disk.
Just like that. And if there's more data in the queue, the whole process starts over for the next block.
It's like this well-oiled machine.
Constantly processing and organizing your data.
So this entire process, as complex as it is all designed to make sure data is stored correctly.
And efficiently.
Exactly. Correctly and efficiently.
We want it to be reliable.
What happens if something goes wrong during this process?
Ooh, good question.
Like, say, a network interruption. Could we lose data?
Well, ClickHouse has this really clever mechanism.
For preventing that?
Yeah, it's called idempotent inserts.
Idempotent inserts. Interesting name.
Basically, if a client tries to reinsert the same data, ClickHouse can recognize it.
And it skips it.
Exactly. No duplicates.
So it's like a safety net.
I like that. A safety net to catch any dropped data.
That's pretty clever. But even with all these safeguards, there's still another challenge ClickHouse has to deal with, right?
That's right.
As more and more data comes in.
We need to keep things organized.
Because all these new parts being created, they can start to clutter things up, right?
They can. And that's where ClickHouse's merging process comes in.
Merging. Okay, this is getting really interesting.
It's like having an automatic cleanup crew.
Keeping everything neat and tidy.
Exactly.
And that's where we'll pick up in the next part of our deep dive.
I can't wait.
Me neither. Okay, so we're back and ready to talk about this merging process.
This merging process.
It sounds like ClickHouse's way of keeping things organized behind the scenes.
You got it. It's all about keeping things tidy.
All right, so walk me through it. How does this merging thing work?
Imagine your data is like a constantly growing library.
Okay, a library. I like it.
Every time you add new information.
It's like adding a new book.
Exactly. But if we kept adding individual pages...
Instead of bound books.
Yeah, things would get pretty chaotic, right?
Yeah, it'd be impossible to find anything.
Exactly. So merging is kind of like ClickHouse's way of binding those loose pages.
Into organized books.
Exactly. Into nice, neat volumes.
So it's all about making data retrieval more efficient.
That's the goal.
How does ClickHouse decide when to merge?
Well, it's not random.
Okay, so there's a system.
There's a dedicated background process.
Runs in the background.
Yeah, constantly monitoring the situation.
So it's not on a fixed schedule. It just kind of responds to the state of the data?
Exactly. It's like having a librarian who regularly walks through the stacks.
Making sure everything is in order.
Right. Straightening things up, making sure everything is where it should be.
So when it decides to merge, it doesn't just pick parts randomly.
No, not at all.
Yeah.
There are some smart strategies involved.
Oh, I bet.
It considers things like the size of the parts, any ongoing merges, and the overall number of parts in the table.
So it's almost like a game of Tetris.
Yeah, like Tetris, finding the best fit for all those parts.
I like that. So now we've got ClickHouse merging these parts together. What else?
Well, here's where things get really interesting. Sometimes, some data might be written to disk multiple times.
Wait, multiple times? That doesn't sound very efficient. Like copying the same book twice?
It might seem that way, but ClickHouse is smarter than that.
Okay, good.
It uses a technique called copy on write.
Copy on write.
And basically, if a block of data already exists in one part, it doesn't need to be copied again.
So it's like A smart copy and paste, that only copies the new stuff.
Exactly. ClickHouse is really good at avoiding unnecessary work.
Okay, that makes me feel better. So this whole merging process, it's happening behind the scenes, right?
All behind the scenes. You don't even have to think about it.
ClickHouse is just taking care of business.
Exactly. Keeping things organized and efficient.
All right, so we've talked about how data is written, how it's organized.
Right.
But what about actually getting the data back out? How do we find what we need?
That's a great question. Remember that sparse primary index we talked about?
The one that's like a building directory?
Exactly. That's our key to faster riches within each part.
Right, it doesn't list every single row.
Nope. Just points to ranges of data.
Like chapters in a book.
Perfect analogy.
So instead of scanning millions of rows,
Which would take forever.
it can just jump to the relevant section.
Exactly. It's so much faster.
So let's say I want to find all the records for a specific user ID.
Okay, perfect example. ClickHouse would use that index to narrow down the search to just a few granules.
Within a specific part,
Right. It's like knowing which chapter to look in.
instead of flipping through the entire book.
Precisely. Saves you a ton of time.
What happens next?
Once it knows the right granules, ClickHouse uses those mark files. Remember those?
The bookmarks.
Exactly. To pinpoint the exact location of the data within those compressed blocks.
So the index gets us to the right chapter.
Yes.
And the mark files tell us which paragraph to read.
You got it.
I'm really starting to appreciate how all these pieces fit together.
It's a pretty amazing system.
Now, because ClickHouse stores data in columns, it only needs to read the columns that are relevant to the query.
Right. No need to read everything.
So it's like grabbing just the ingredients you need from the pantry.
Instead of bringing the whole pantry to your cooking station,
I like that.
it's all about efficiency.
So MergeTree is designed to minimize the amount of data that needs to be read, making queries blazing fast.
That's the goal?
But what happens if our query needs to filter on columns that aren't part of the primary key?
Another great question. ClickHouse has something called table projections for that.
Table projections.
Yeah, think of them as alternative versions of your table,
Okay, different versions.
each sorted by a different primary key.
So it's like having multiple indexes for a book.
Like that.
One by author, one by title.
Exactly.
So depending on my query, ClickHouse can choose the most efficient way to access the data.
Precisely. It's like having that personal librarian who knows exactly where everything is.
This is getting more and more impressive.
It is a pretty clever system.
Are there any other techniques ClickHouse uses to speed up data retrieval?
Oh yeah, there are. ClickHouse also uses what we call skipping indexes.
Skipping indexes, what are those?
They help us quickly eliminate blocks of data that aren't relevant.
Okay, tell me more. How do they work?
Well, a common one is the min-max index.
Min-max, okay.
It stores the minimum and maximum values for each block.
In the index.
Yeah. So if your query is looking for a range of values.
Like sales between certain dates.
Exactly. ClickHouse can just skip over blocks that don't fall in that range.
It's like knowing that all the Jane Austen books are on the second floor of the library.
Love it.
You can skip the entire first floor if you're looking for a different author.
Exactly. You don't even have to look there.
It's all about finding those shortcuts.
Absolutely.
All of these indexing techniques work together to make ClickHouse incredibly efficient at finding the data you need.
That's right. They all work together.
It's amazing how much work has gone into making ClickHouse so fast.
Yeah, it's a really impressive system.
But we haven't talked about updates and deletes yet.
True, we haven't.
Those seem a lot trickier than just adding new data.
They can be. Remember, MergeTree is all about appending data.
Right, like adding entries to a log file.
Right. It's designed for that continuous stream of information, changing existing entries or removing them.
It's like trying to edit a printed book.
That's a good way to put it. It's not impossible, but it's definitely a bit harder.
So how does ClickHouse handle it?
Well, ClickHouse handles updates and deletes through something called mutation tasks.
Mutation tasks.
Yeah. And these tasks, well, they basically rewrite the parts that need to be changed.
Okay, so they're like issuing a revised edition of the book with the updated content?
That's a good way to think about it.
But wouldn't that be really inefficient if you're just changing one row?
Yeah, you're right. Rewriting an entire part just to change one row would be overkill.
Right.
But ClickHouse has a faster option for deletions.
Oh, what's that?
It's called a lightweight delete.
Lightweight delete. All right, tell me more. Lightweight delete. All right, tell me more.
Okay, so instead of rewriting the whole part, a lightweight delete just marks rows as deleted.
Marks them as deleted. But they're still there.
Well, yeah, kind of. It uses an internal bitmap.
A bitmap?
Yeah, think of it like striking through a sentence in a book.
Instead of erasing it?
Exactly.
Yeah.
The text is still there, you just kind of ignore it.
So it's more like hiding the data.
Yeah, that's a good way to think about it.
Does that affect how fast queries run?
A little bit.
Mhm.
When you query the table, ClickHouse has to check that bitmap.
And skip over the deleted rows.
Right. But it's still a lot faster than rewriting the whole part.
So it's a trade-off.
Yeah. Faster deletes, maybe slightly slower queries.
Interesting. So what if I have a ton of updates and deletes happening all the time?
For that, ClickHouse has some specialized MergeTree engines.
Like what?
Well, there's replacing MergeTree.
Replacing MergeTree, all right. What makes it special?
Replacing MergeTree, it only keeps the most recent version of a record.
Oh, okay. So no more worrying about old versions.
Exactly. It uses the creation timestamp of the part.
To know which one is newest.
Right.
Yeah.
And then those older versions, they get automatically deleted during merging.
It's like a self-cleaning closet. Gets rid of the old stuff to make room for the new.
I like it.
Sound like ClickHouse has a MergeTree engine for every situation.
Pretty much.
We've talked about how data is written, read, organized, even changed.
Oh.
But there's one more big thing, right?
Yeah, replication.
Replication.
That's right.
How does ClickHouse make sure our data is safe?
Safe and available, even if something goes wrong.
Available across multiple servers.
Exactly. Every MergeTree table has a corresponding replicated engine, like replicated MergeTree or replicated replacing MergeTree.
So it's like having multiple libraries, each with a copy of the same book collection. But how do they stay in sync?
Well, ClickHouse uses something called table states.
Okay, table states.
They basically include all the parts and metadata for a table and every operation.
Every insert, every merge.
All of it. They're all recorded in a replication log.
So it's like a log of every change that's made to the data.
Yeah, you got it. And that log is maintained by a set of ClickHouse keepers.
Whole keepers.
Yeah, using the Raft consensus algorithm.
Raft. Okay.
It's a pretty sophisticated system, and make sure all the replicas have the same data eventually.
Even if some things happen out of order.
Even then, yeah.
So even with multiple servers and all these asynchronous operations going on, ClickHouse is making sure the data stays consistent.
That's the idea. Replication is about making sure your data is highly available, scalable, and consistent.
Wow. We've really gone deep today, explored the ins and outs of ClickHouse's MergeTree engine.
We have.
It's incredible how much complexity goes on under the hood.
It is pretty remarkable. All designed to handle massive amounts of data and make it really fast and efficient.
You see, MergeTree isn't just about storing data. It's about carefully controlling how it's written, organized, accessed, modified.
And replicated.
Right, and replicated, of course, to really unlock the power of ClickHouse for all your data needs.
And the best part, it's really flexible. You can tune it to fit your needs.
Customize it for your data.
Exactly.
It's like having a custom-built engine.
I like that analogy.
Well, we've only scratched the surface today, but hopefully you've got a good foundation now.
A good starting point.
And if you're ready to learn more, I definitely encourage you to dig deeper.
There's a lot more to explore.
Until next time, keep exploring, keep learning, and keep diving deep.